Hello, welcome to India's most comprehensive e-learning platform BYJU'S Exam Prep, and also special welcome to ECE and electrical as well as instrumentation students for this wonderful series, that is GATE AIMER'S series. As a part of the discussion, currently we are discussing about the circuit theory subject. Of course, so far I have handled 4 lectures in circuit theory subject, and right now we are here and we are about to discuss one more important topic all the way about the resonance. As I told you already, we already done 4 lectures. If anyone has any doubts related to supermesh analysis or supernodal analysis, or else even if you have any doubts related to Thevenin theorem and maximum power transfer theorem, please visit my previous 4 lectures. You will get beautiful idea about it. As a part of the discussion, as I already promised you, we are going to discuss now a special topic which is nothing but resonance. And if you are a sincere student or if you are a serious aspirant, you know what is the importance of the concept resonance, correct? So more or less all the way, if you refer the overall GATE paper, you will be getting one question at least which refers to the resonance. Am I right or not? So that's why I came up with the discussion, that is resonance. Chandrasekhar, good evening, very good evening Chandrasekhar. Well, without wasting the time, let me get into the topic directly. But before going to the topic, for the new students, let me quickly introduce about myself. As you all can see, myself Phanindra, all put together, I have an experience of 11 plus years teaching for both ESC aspirants as well as GATE aspirants. So far, I have guided so many students in the subject of control system, circuit theory and measurements and industrial instrumentation. Sudarshan, good evening. Ashok and Ashok, good evening. Good evening every one of you. And I really am very happy to see a lot of sincere students who are coming so regularly. Please keep the same momentum till the end of your examination. Go with the same confidence, go with the same commitment. I'm very sure you will all get success. Okay. So moving ahead, already as I said, we're done with this first section, and then this is also completed, and even the Thevenin theorem and maximum power transfer theorem, all these first 4 lectures are completed. Currently we are in the last lecture, that is resonance. Of course, if anyone has any doubts related to circuit theory and control system and especially industrial instrumentation, you can connect with this Telegram link. All the way you can chat with me, and I am very sure you will going to get the reply in 24 to 48 hours of the time. Clear? So moving ahead, today we are here, as I said, we will be speaking about the resonance. What do you mean by resonance? Right? Sir, how you talked GATE 11 times, wonderful. See, Chandrasekhar, I love GATE examination. It is like a festival for me. Every year, every one of you might be waiting for Diwali, right? But I myself waits for the GATE examination. Probably the last year was the year I didn't appear for the GATE examination because I was affected by COVID exactly during that time. And this year also I'm going to write GATE 2022 also, right? So 2023, sorry, right? So moving ahead, what do you mean by resonance? Any one of you? Any one of you, can you briefly tell me what you mean by resonance? In a simple way, I will tell you, you all are listening my class, right? So if I am teaching at some particular frequency, right? So I may be very fast, or I may be very slow, or I may be neutral. So the audience who will be tuning to my frequency, they will get lot of benefit from my lectures, correct? They are going to get lot of benefit from my lecture. So in that case, I can say both me as well as the students' connection all put together, we are at resonance. Clear? So in simple word, what I can say is, at resonance, the response is to be maximum in the circuit. So our resonance is a state of the situation where we can see the maximum response will come, especially in series RLC circuit. Clear? Sir, please share the Telegram link. Sure. Already it is there on the first slide. If we wait till the last slide, there also you will find my Telegram link. Okay? Right. So now let me go ahead with the formal definition of the resonance. As I already told you, I may be teaching very fast or I may be teaching very slow. Definitely some other teacher might be teaching in the different format and different pattern, right? So there are some students who will connect to me, and there are some students who will connect to that particular faculty, correct? So in that case, I can say those people who are tuning to my frequency, they will going to get maximum output from me, right? So in that situation, I can say the ecosystem which is formed is at resonance. Clear? I hope this example helps you a lot, right? So resonance is a condition in an RLC circuit in which the capacitive and inductive reactances are equal. Inductive reactance are equal in magnitude, thereby resulting in a purely resistive circuit. Okay, fine. This is the what I should say is a mathematical definition. To be honest, this is a mathematical definition. But intuitive definition, as I said in the previous 1 or 2 minutes back, I already given a formal definition. But let me tell you once again, resonance, especially in series RLC circuit, it is a state where the maximum response can be obtained in the circuit. Clear? Very good evening, Surya. Very good evening. Right, so moving ahead, suppose if I say there is a voltage source here. Let me take a simple voltage source for all the way so that you will understand this in the better way. Let me assume that we have a voltage source here, and maybe this is the RMS voltage at an angle of some phase here. Okay, so this is an AC source, and we all know that inside the circuit we will be having so many elements, maybe resistors, maybe inductors, maybe capacitors, right? So suppose if this circuit is drawing all the way the current from this particular voltage source, let me say it is drawing some amount of current. For time being, let's assume that I is the RMS value of the current. So at resonance, we will be seeing maximum value of I that will be taken by the circuit from the voltage source. Indirectly, what I say is, in this particular session, so for example, if I say I am faculty, right? I am faculty. So let me say simple example I am giving. So I am faculty here, right? And you all are students, right? So you all are students. Now, what is going to transfer from the faculty to the students? Obviously, knowledge will be transferred, correct? So knowledge, let me say here in this particular example, knowledge is considered as a current. Clear? Knowledge is considered as a current. So resonance is a state where the maximum current can be transferred from the voltage to the circuit. Similarly, resonance between you and me is a state where the maximum knowledge from the faculty will be all the way shared to the students. Clear? All the way it is shared to the students. I hope you understood what is the fundamental logic here, isn't it? Please tell me in the comment section, is the example is clear? So I don't want to put more effort in the example. If I keep more effort in the example, then obviously you will miss the technical content. But I hope you understood what is the meaning of the resonance. But in the statement, there are some things which you must understand here. So it was mentioned clearly, reactances of capacitive as well as inductive reactances are same. That is, XL must be equal to XC. Already some of you might have already mentioned. Ashok has already told this, right? Ashok has already commented this. That is, XL is equal to XC. Fine. At the same time, the overall impedance of the circuit, suppose if I say this is A and this is B, the overall impedance that is offered by the circuit between A and B terminals must be equal to resistance. That means it should be a purely resistive circuit. Clear? So the circuit should turn out to be only purely resistive circuit. Then I can say the circuit is at resonance, and these two conditions are valid irrespective of the pattern of the circuit elements. That means you can use these two conditions even if the circuit elements are connected in series, even if the circuit elements are connected in parallel configuration. Hope you understood, all of you. Please let me know in the comment section, so far whatever I have explained, is it clear to every one of you or not? Please tell me in the comment section. That will give the energy to me. Once I excited, naturally we all will be in resonance. So please tell me, is it clear to every one of you? Right. So now, how do we analyze the resonance? This is a very, very important thing, right? Because understanding that formal definition of the resonance is one level of one level of important thing. But at the same time, how do we use that resonance in our circuit, and what are all the important factors that we need to keep in mind as far as the GATE exam is considered? These things we are going to discuss now one by one. Sir, I think this is the only chapter from where most of the conceptual questions came in the GATE. That's exactly what I am saying, Pramit. right? This is the reason why even in the recorded lectures, BYJU'S Exam Prep, I have handled almost around 4 lectures on resonance with a practical example. Where do we use the resonance, like how FM will be selected, right? Because every day we have habituated to listen FM, right? So how we are tuning, what is happening at resonance, and exactly how our microphones are able to capture that frequency. All these things I have explained in the recorded lectures. However, in 1 hour, let me do what I can do to the best. How do we analyze the resonance? Number 1, if you have series RLC circuit, suppose if the resistance and inductor and capacitor all are connected in series, then resonance is the condition in which current in the circuit will attain its maximum value. Please try to understand this. So in series RLC circuit, current should attain the maximum value and impedance will be very, very small. That means impedance should become minimum as far as the RLC circuit is considered once you go for series RLC circuit. So I'm sorry, recorded lectures are free or not? So some of the recorded lectures are free. So if you want to visit only resonance, yes, you can see that. But all the lectures, it is not available for free of cost. That is as far as my knowledge is considered. And the second is resonance in parallel RLC circuit. Resonance is a condition in which the current in the circuit will attain minimum value. Please try to understand. Both are actually different here. Here it is resonance in series RLC circuit and resonance in parallel RLC circuit. Here we will be getting the maximum current in the circuit. Here we will going to get the minimum value of the current in the circuit, and the impedance will become maximum in in parallel RLC circuit. Clear? So in parallel RLC circuit, impedance should become maximum. Hope you understood. This is exactly different and opposite to the series RLC circuit. Is it clear? Here the current will become maximum because the impedance will be minimum. Clear? So impedance will be minimum. And here you must understand that current is actually minimum either because the impedance is minimum or the admittance is minimum or impedance is maximum. Clear? So this is exactly ulta, right? So now let me move ahead and take a simple series RLC circuit for the better understanding. And hereafter, please promise me you have to stay till the end, then only you will understand each and every concept so clearly. In between, if you leave, I am not responsible if you are not understanding, right? So let me go ahead and discuss about series RLC circuit. All of you, please pay more attention here. So here you can see we are having a sinusoidal voltage source. Clear? Of course, V stands here RMS voltage and at an angle of phase. So let us say maybe it is taken as 0 only for better and easy purpose. So V at an angle of 0. So now when we have V at an angle of 0, this particular voltage source is delivering the current capital I. And trust me, this is also RMS value of the current. RMS value of the current. Now we all know that the current will all the way circulate in the loop and finally come back to the voltage source like this. Now when you deal with the AC circuit, it is better to play with the RMS values. Now can you tell me what is the overall impedance of the circuit now? Overall impedance of the circuit can be written as resistance. First we have a resistance plus we have an inductance. So let me say this is going to be plus J times of XL here, and then one must understand that this is C. So it has to be like minus J times of XC here, correct? Minus J times of XC. Relax and go ahead, right? So moving ahead, what else we can say? Z is equal to R plus J into, we can take outside, here XL is nothing but omega L minus XC is nothing but 1 divided by omega C. So XL and XC are considered as the reactances of inductance as well as capacitor. This is the overall impedance of the circuit. Now what I told you, resonance can attain when the reactance of inductance and the capacitors both must be same, right? So that means I could say that at resonance, especially at resonance, so please try to see clearly, at resonance the reactance of the inductance and the reactance of the capacitors both will be same. Therefore I can say omega L is equal to 1 divided by omega C, and from this we can all the way say that omega square is equal to 1 by LC, and from this again we can rewrite that omega is equal to, of course plus or minus will be there, but I am not worried about minus here. So 1 divided by LC, radians per second, and this is called as the resonant frequency. Clear? So that means whenever your frequency of the supply, because we all know that the supply voltage Vs of t would be a sinusoidal signal, correct? So sinusoidal signal, I can say Vs into sine omega t. So, and this is a variable frequency. So that means we will vary the frequency. How long we will vary the frequency? We will vary the frequency, vary the frequency, vary the frequency by the time when the frequency is equal to 1 by under root of LC. Clear? Once the input signal frequency and 1 by root LC both are same, then you will going to see the resonance in the circuit. Clear? Either we will vary the frequency or we will fix the frequency and change the value of capacitor or inductor. Clear? Both the cases are possible. Either we can fix the frequency here and change the value of either L and C such that 1 by root LC will become input frequency. That is one case. Second case is we will change the frequency and fix the value of L and C. But ultimately what should happen here is whatever the frequency you are writing here, that must be equal to the value what we are having here. Then we can say yes, resonance occurred. Clear? So this is omega r. But how do we write the frequency? So omega r is equal to 2 pi f. So fr, that is equal to what? Omega by 2 pi, right? So let me write down omega r divided by 2 pi in terms of hertz. So it will be like 1 by 2 pi into under root of L into C. Of course, as I said, this is hertz. Clear? So now you might understood clearly what is the state of resonance and when do we get the resonance, right? Remember this very, very clearly. In case of instrumentation, frequency will be constant and we will change the value of capacitance. In case of electronic circuits, what we do is inductance and capacitance are constant and we will change the frequency. But ultimately the concept of resonance remains same. Is it clear to every one of you? Please let me know in the comment section. All of you please fast. Now at resonance, impedance is what first of all? So we have already seen that the impedance would be equal to R plus J into, of course I have already told you that omega L minus 1 divided by omega C. Then if you calculate the magnitude of impedance, the modulus of impedance would be written as under root of, look at this clearly, R square plus omega L minus 1 divided by omega C whole square. Clear? Right, very good. S, very good. Where is Pramit? Pramit, is it clear to you? Ashok and Surya, Siddharth, please let me know. Is it clear to you so far whatever I am speaking? Okay. So now this is the modulus. That means the magnitude of the impedance. Now as I said, at resonance what will going to happen? At resonance, as I said, at resonance omega R is equal to 1 divided by, first of all, omega L and omega C both are same here, and omega R is equal to under root of 1 divided by under root of LC, right? If you put this, then you will understand clearly that what is the nature of the impedance now. Now look at that, the impedance, what it will going to become. This will turn out to be Z is equal to simply like resistance R. This is very, very important. I hope you really got the point here, correct? So now moving ahead, what are the voltages across each and every element? Now whenever you see the overall impedance at resonance equal to R, overall impedance is R, then what is the value of the current that is flowing now? I is equal to, go back here, how can I write I here? So the supply voltage, that is V at an angle of 0, divided by the overall impedance is only resistance here, correct? So I need not to take much effort here. I is equal to V divided by magnitude of Z, modulus of Z I need to write. But right now modulus of Z is how much? Simply it is resistance R only, because at resonance the impedance is purely resistive in nature. So therefore let me write down here this as V divided by R. Very easy. This is simple to understand. But what is the value of voltage across the inductor now? Voltage across the inductor. Any one of you, can you tell me? Look at this and tell me what do you mean by voltage across the inductor? If you ask the same question, I can simply say that voltage across the inductor is equal to same current is flowing here, current through the resistor and current through the inductor and current through the capacitor, and all this will be equal to current I. Am I right? All these are equal to current I. Why? All are connected in series. As all are connected in series, without waiting for the second time, I can say voltage across the inductor equal to current flowing through the inductor, that is simply like I only, into if you are looking for the magnitude, then obviously I should say that because it is magnitude, I am writing only magnitude of inductance. So this will be equal to XL, correct? So moving ahead, the value of I would be saying as V divided by R into XL is nothing but omega L here, correct? Omega L, and that I can say omega L divided by R, of course, into the applied voltage. And this omega L by R, what it is called? Any one of you, please let me know in the comment section. Ansari, Surya, Chandrasekhar, Suraj, and as well as so many students are there. Please mention what is this omega L by R. Omega L by R would be considered as a quality factor. So therefore I could say it will become Q times of voltage V. Q times of voltage V. Clear? So that means the final answer to this overall theme here is the voltage across the inductor will be equal to Q times of the supplied voltage. That means Q is usually more than 1. Q is more than 1. That means suppose if I say Q is equal to 5 and the supplied voltage amplitude is 2 volt, right? Then what is the voltage across the inductor? Voltage across the inductor would be given as 5 into 2, that is equal to 10 volt. This is magnitude. I am not looking at the phase. I am not looking at the phase. I am only considering the magnitude. That means the magnitude of the voltage across the inductor is Q times the magnitude of the voltage across the voltage applied. Q times the voltage applied. Clear? Now even the same thing will going to happen even if you look at the VC also. What is voltage across the capacitor? That could be said as current flowing through the capacitor into reactance of the capacitors. So easy. Current flowing through the capacitors into reactance of the capacitors. So what should I say here? Any one of you? Current flowing through the capacitor into reactance of the capacitors. Pramit, answer from your side. No answer from your side. So this will be equal to how much? I into, I could say 1 divided by, right? So 1 divided by omega into R into C. Sorry, I is actually nothing but I am extremely sorry. I could be written as, so let me write down here. Just give me 1 second time. I is nothing but V divided by R into 1 divided by omega C, right? 1 divided by omega C. Therefore, we can write down 1 divided by omega into R into C into supply voltage. And in this case, 1 divided by omega RC is considered as a quality factor. So again, this is going to be Q into V, right? So all put together, magnitude of the voltage across the inductor will become Q times of the supply voltage. At the same time, magnitude of the voltage across the capacitor also will become like Q times of the applied voltage, right? However, phase will be anti. Phase will be anti means here we are going to have positive phase, here we are going to have equal negative phase. But when you consider the total voltage in the circuit, that remains as a supply voltage. But when you look at the voltage across the inductor, you will have a magnified form of the voltage. That's why series resonance circuit is called as magnifier. Clear? Magnifier of voltage. Clear? Magnifier of voltage. So please remember this point. This is very, very important point. All of you please tell me, series resonance circuit, series RLC circuit acts like a magnifier or attenuator. Sir, in any random circuit, how to find Q? I will explain. I will explain, Pramit. Don't worry. I will explain. Right? So I will definitely explain. Just wait for some time. Now moving ahead, impedance already we have seen. See, I think after this, just only 15 minutes class is over. 20 minutes is over. After 5 to 10 minutes, we will come to the quality factor calculation. I will explain, don't worry. I know what you require, so please concentrate here. So the magnitude of impedance, when you see, particularly the modulus of impedance, if you see, it will be equal to under root of R square plus omega L minus 1 divided by omega C whole square. Clear? So generally what happens is at lower frequencies. So if omega is low, that means if you are having a lower frequency, omega is low, then obviously 1 by omega C is going to dominate omega L, correct? 1 by omega C, because omega is in the denominator. If omega is low, 1 by omega C will be more than omega L. Am I right? So this means easily we can say XC is more than XL. So in that case, the circuit in the low frequency region, low frequency, this is considered as a low frequency region, it acts like a capacitive because the impedance of the capacitance will dominate the reactance of the inductor. At the same time, this is one aspect. Second aspect is omega. If omega is high, then what will going to happen? If omega is high, then I can say omega L will be more than 1 divided by omega C, because high value of omega, if you keep in the denominator, this value will be low compared to omega L. Therefore, I could say that XL will be greater than XC value. Simple. XL is greater than XC. Therefore, at high frequency, one must really appreciate and understand this. That is, at high frequency, the circuit acts like inductive. That means almost the circuit acts like a inductive. Very, very simple. But what is exactly at the resonant frequency? Exactly at resonant frequency, that means at omega is equal to omega R, you must notice the fact that the Z, magnitude of Z will be equal to resistance R. Simple. So that means this value is considered simply as R here, right? Now, keeping this point in the mind, what I would like to say is, look at that. At low frequency, the impedance is actually decreasing. Correct? Impedance is decreasing. At resonant frequency, we got the minimum value of the impedance. Minimum value of the impedance. Again, when we increase the frequency, again we are seeing the impedance is getting increased here. Correct? So what does it mean? At omega is equal to omega R, we are going to see the minimum value of resistance. That means we are going to have the maximum value of the current. If the impedance is minimum, the current flowing through the circuit will be maximum. Simple. So therefore, exactly at omega is equal to omega R, one can see the maximum current I max, which is equal to V divided by R here. In fact, this is the RMS value of the current here. Clear? So let me say a maximum value of the current that is flowing through the circuit is V by R, where V is the RMS value, R is the resistance, I is the RMS current here. Clear? Now, here comes the most important thing, that is bandwidth. Most of the people, they don't derive what is the bandwidth here. But as you all know that I am not that kind of teacher. So let's try to understand what is the bandwidth here. So any one of you, what do you mean by bandwidth here? Bandwidth means the power should become half of that, right? So that means it is the frequency range at which the value of the current will become like half of the maximum value of the current. I max divided by root 2 here. Clear? I max divided by root 2. Understood? I max divided by root 2. And at the same time, exactly at this value of frequency also, you are having I max by root 2. So that is omega 2. Now, if the current is I max by root 2, what would be the power? Any one of you? What would be the power? So power, if you look at power calculation, let me tell you clearly, the power consumed by resistor, for example, resistor only. So I square into R. Am I right? I square into R. So simple. Here IRMS square. So therefore, I could say that, so when the current is equal to I max by root 2, what it will going to become? IRMS value will going to become I max by root 2 whole square here into R, right? Whole square into R. So this will become like I max square into R divided by 2. This is nothing but maximum power divided by 2. Am I right? Maximum power divided by 2. That means when the current equals to I max by root 2, the power will become P max by 2. I repeat, when the current equals to I max by root 2, then the power will become P max by P2. So P max by 2. This means logically I can say exactly at omega is equal to omega 1. Okay, so please try to understand clearly. At omega is equal to omega 1, because if you understand series resonance clearly, then parallel resonance is cakewalk to you. Just like that we can complete it. In the maximum 10 minutes we can finish everything. So please see here. At omega is equal to omega 1, specifically the current in the circuit is becoming either I max by root 2 or the power is going to become like at the same time. So I am seeing that the power will going to become half of the maximum power, that is P max by 2. That's why omega 1 and omega 2 are called as a half powered frequencies. I repeat, half powered frequencies. Sometimes even the questions will come like this. Please tell me what is the value of the half powered frequency. That's why I have explained this. All of you mentioned in the comment section. Today I want the reply from your side. Is it clear to every one of you or not? If the current becomes Imax by root 2, power will become Pmax by 2. All of you please tell me in the comment section. Pramit, Ashok, Amsari and Chandrasekhar, Chandu and Surya. Please tell me, is it clear? Half power frequency means, what do you mean by half power frequency? The frequency at which the current becomes Imax by root 2 and power will become half. Simple. Now how do we calculate that? That is an important question. How do we really calculate that? So we already seen that the value of I equals to the value of I is equal to, look at that. So we have seen that the value of I is equal to V divided by the magnitude of impedance. So let me write down R square plus omega L minus 1 divided by omega C whole square. Am I right? This is so simple to understand. This is the general value of the current here, correct? So now specifically speaking here, exactly at omega is equal to omega 1, omega is equal to omega 1, what should happen here? Just look at this. Omega is equal to omega 1. What might be happened here? So at omega is equal to omega 1, the current should become Imax by root 2, correct? So Imax by root 2. So let me say this is going to be Imax by root 2 here without any second thought. This is Imax by root 2. And right hand side we are having like V divided by under root of R square. Please see here. You need not to remember anything. If you follow me, automatically you will be able to understand everything. The only thing is you must have patience and confidence on me, right? This is exactly what you will be getting. So bandwidth is given by R by L. I'm sorry, excellent, I'm sorry, but we need to show that, right? So Imax by root 2. But what is Imax according to us? The maximum value of current what we can see in the circuit is V by R, right? So let me write down Imax is V by R. So this will become now root 2 into R, and right hand side we will be having like V divided by under root of R square plus omega L minus 1 divided by omega C whole square. This is very, very important. Now square on both sides. If you square on both sides, what you will going to get here? So here we will be getting here, once again, you will be getting V square divided by 2 times of R square. Am I right? So that's all. Square on both sides. V square divided by 2 times of R square, and right hand side also you will be having like V square all the way divided by R square plus omega 1 into L minus 1 divided by omega 1 into C whole square here. So all of you please try to see. This is omega 1 and this is omega 1, omega 1, omega 1. Initially it took a little bit time, but trust me, once you habituate this, easily you will be able to understand. I will also give the shortcut to remember this also. Now tell me, this will go, this will get cancelled here, and this is 2R square. Already R square is there. So that means this total, what it will going to become now? Omega 1 into L minus 1 divided by omega 1 into C. It has to become plus or minus R here. Clear? Plus or minus R. But try to see here, omega 1 is actually less than omega R. Means it is a low frequency zone. If it is a low frequency zone, omega 1 is less than omega R. That means it is a low frequency zone. If it is a low frequency zone, naturally this value is actually smaller compared to this value, correct? Compared to this value. That means omega 1 L is less than 1 by omega 1 into C. That means I can say confidently that omega 1 into L minus 1 by omega 1 into C, obviously it will going to become minus R here. Clear? Minus R. This is first equation one must actually keep in the mind here. Okay, this is the first equation. And of course, if you solve this equation, then you will going to get the value of omega 1. So it is a quadratic expression. Just take the LCM and do all the stuff here. Then you will going to get omega 1 is equal to minus R divided by 2L. Clear? Minus R divided by 2L. Of course, plus or minus we will be having under root of R by L whole square, right? And of course, you will going to have some value here, right? What I do is, I will give this value to you. So it is a half powered frequency. If you want, you can see what exactly you will be having here. But as far as my knowledge is considered, you will be having 1 by 4 AC you require to keep, right? One second. So if you want, you can take it, no issue, because some people might be interested to see what exactly it is going to come here, right? So just give me 1 minute time. I will be doing this. You will also feel happy when you know everything clearly, right? So moving ahead, what should I say here? Omega 1 square into LC minus 1 divided by, minus 1. So let me write down clearly. Minus 1 here. So omega 1 square into LC minus 1, and right hand side you will be having minus omega 1 into RC here, right? So then obviously you can bring this to this side, omega 1 square into LC and plus omega 1 into RC, and what about this one? So omega 1 square into LC and plus this one and minus 1, that is equal to 0. And moving ahead, from this easily we can say, so please try to apply your common sense. Divide both sides with the LC. So then you will be having clearly like omega 1 square plus what you will have here. So when you divide with LC, you will be having like R divided by L. Of course, omega 1 will be there, minus 1 divided by LC. After a lot of hard work, you might got this equation. This is the quadratic equation. If you solve the quadratic equation, omega 1 will come as minus B, right? Minus B plus or minus 2A. So minus plus or minus B. So what you will going to get here? All of you please see here. Minus R divided by 2 times of L. Correct? 2 times of L. Plus or minus under root of, here 1 by 2 will be there first of all. Under root of minus B plus or minus under root of B square minus 4AC. That means R divided by L whole square here. R divided by L whole square minus 4AC. So it will be minus of minus plus 4 times of AC, 4 divided by LC here. Clear? So now if you still write down in the better way, you will going to get like minus, this is omega 1 and omega 1 plus or minus under root of, so please see here, R divided by 2 times of L whole square plus 1 divided by LC. I hope you understood this clearly. So though I have taken some time to solve this, because I personally believe that in many of the materials as well as in most of the teachings, they will not derive this half powered frequencies. They will straight away give the formula of bandwidth as R by L. But let me show you here, otherwise you will not get anywhere. So please appreciate me by taking 1 minute time at least. Omega 1 is equal to this. Now omega 1 could not be a negative frequency. In that case, what I can say, omega 1 could not be negative means frequency cannot be negative. So it must be like minus R divided by 2L plus under root of R by 2L whole square plus 1 divided by LC. Correct? 1 divided by LC. Right? So just I have taken 5 minutes time. I am calculating this 5 minutes of time, but you might got exact proof here, right? So omega 1 is equal to this. Omega 2 is what? If you do in the similar format, right, omega 2 means again we have to keep omega is equal to omega 2, and same approach you will going to follow. Everything is same. The only thing is when we put omega 2 here, as we can see, omega 2 is more than omega R. Omega 2 is more than omega R. Every calculation is same. Instead of minus R, you will going to get plus R here. That is the only difference. Rest of everything is same. Rest of everything is same. Therefore, I can say if you calculate omega 2, you will be getting like R by 2L plus under root of R by 2L whole square plus 1 by LC. Clear? So these two frequencies are called as a half powered frequencies. Now let's come to the Ansari's discussion. So Ansari is saying that bandwidth is how much finally. So after this much of elaborated explanation, we can say bandwidth. Bandwidth is actually nothing but what? Bandwidth is considered as delta W, that is equal to omega 2 minus omega 1. Correct? Omega 2 minus omega 1. Omega 2 is known to you. Omega 1 is known to you. Now omega 2 minus omega 1 if you do, you will going to get 2 times of R divided by 2 times of L. So then you will going to have R divided by L. All of you, please let me know how many of you are very clear about calculation of this bandwidth in today's lecture. So how many of you got to know this is for the very first time? Okay, so even if you have already know, I am the happiest person. You can consider this as a revision. If you don't know, at least now feel happy that you came to know how the bandwidth is calculated. Clear? So well, after calculating the bandwidth, now it's the duty of quality factor. As Pramit asked earlier, now let me explain you the easy way to calculate the quality factor. Very simple way to get the quality factor of any element. Quality factor will not be decided only for the entire circuit. We will have a quality factor for capacitor. We will be having the quality factor for inductor also, right? So how do we find that quality factor? So in simple way, Q is equal to 2 pi. Most of the textbooks, they will not mention this 2 pi, but 2 pi must be there. So please keep in your mind, 2 pi must be there. At the same time, energy stored in the inductor or capacitor per cycle divided by energy dissipated per cycle. Energy dissipated per cycle. So how can I write this one then? Then quality factor is equal to 2 pi times, very good, into energy stored in the inductor. Let us take this one. Energy stored in the inductor. How do we write the energy? Energy stored in the inductor could be written as half times of L into I square. Correct? Half times of L into I square. Right? So maybe this could be like, I could say that it is I max actually. Correct? So this same divided by the power dissipated per cycle. Right? So because the current remains same here. So 1 second. I'll tell you in the easiest way. How do we find the energy stored in the inductor? Energy stored in the inductor, as we are in series RLC circuit, the current through each circuit, current through each element is same. So we have to take current as a reference here. Current as a reference because current is same throughout all the elements, inductor, resistor and capacitor. So therefore, the energy stored in the inductor can be written as half L into I max square. Usually this is the formula for this. Correct? So but if you go ahead, it should be written as L into I max divided by root 2 whole square here. So this is exactly what it is considered, right? Therefore we can say clearly that this is L into IRMS whole square. Simple to understand. L into IRMS whole square. Please don't get any confusion. Pramit, please let me know, is it clear to you or not? Pramit Banerjee. IRMS square, L into IRMS square divided by energy dissipated per cycle. What do you mean by energy dissipated? Energy dissipation happens only through the resistor, correct? Only through the resistor. So energy dissipation can be written as I square, RMS value of the current square, into the resistance value. This is power, correct? This is power, but we require energy. How do we get energy here? We have power. If you want to get the energy, we need to multiply that with the time period, correct? So one single cycle means time period. Now moving ahead, what should I say here? Any one of you, can you tell me fatafat here? IRMS square get cancelled here, right? And most importantly, we are having like Q is equal to 2 pi divided by T, 2 pi divided by T whole into L divided by R, and 2 pi by T, it is nothing but omega, correct? 2 pi by T is actually nothing but omega. Therefore, I can say it is equal to omega L by R. This is the quality factor of a coil. At resonance, we already know. In fact, omega L by R can be written as XL divided by R. And at resonance, we know that XL is equal to 1 by XC. So therefore, XL is equal to 1 by XC. XC into R, and this can be written as equal to 1 divided by omega into R into C. That's all. Because at resonance, we know that series RLC circuit XL is equal to XC. That's why I have made all this clearly. Therefore, finally the quality factor could be written as, so please see, either omega L divided by R, this is one aspect of writing this, or else we can even say that 1 by omega R into C. And this quality factor formula is valid in series resonance circuit, as we are taking the current as a reference, that means in the numerator and denominator only current should get cancelled, because current is only same here. Clear? How many of you understood this so far? Please let me know in the comment section. Every one of you, please let me know in the comment section. I am waiting for your reply. I expect every one of you must answer this one. So please tell me in the comment section. Waiting for you. Right? Clear. Chandrasekhar is the first person who said it is clear. So that means it's clear. So let's move on to the next and finally look at the summary. At resonance, impedance is equal to resistance. Clear? So let me take another color here. So this summary note, please keep it with you, because it helps you a lot wherever and whichever the example you go, exam you write. Resonant frequency, what is that? Omega R is equal to 1 divided by under root of L into C radian per second. Excellent. Right, moving ahead, next, current equal to, how much is the current? Current is simply like V divided by R here. Well, and bandwidth, which is actually nothing but delta W, and which is equal to R divided by L here. Correct? This is what exactly we got it. R divided by L. Correct or not? So just look at that. Yes, R divided by L. Already I told you. In fact, I have proved it, right? So moving ahead, the next one is a quality factor. Quality factor, either we can write down omega L by R, or we can even say that it is going to be 1 divided by omega into RC. Both are correct. And one more important fact I should say, always try to remember that when we multiply omega 1 and omega 2, just look at what you will going to get. Omega 1 and omega 2, when we multiply, you will understand that this omega 1 and omega 2, just multiply these two. Omega 1 and omega 2, if you multiply, you will going to get omega R square. Omega R square. So this means we can say omega R is equal to under root of omega 1 into omega 2. Right? Well. That's why I am saying that. So this part you can do if you want. Otherwise, these are the basic things what you have to keep in your mind. Just forget about the last one. Otherwise, you can take it as a homework, because as you already know what is omega 1 and omega 2, just multiply omega and omega 2 and see what is its product in terms of omega R. You will really enjoy it. That's why I am saying that you do by yourself. But these are very important. I have covered it. Now moving ahead, next is parallel RLC circuit. Parallel RLC circuit means either you can connect through a voltage source, or simply assume that the current source is delivering some current IS. Clear? Forget about the voltage source. Assume that there is a current source which is delivering the current IS. Now, even in parallel RLC circuit, what you must write here is, the very first thing is IS could be written as equal to, please try to see here, the total current in the circuit is IR plus IL and plus IC here. All these are phasor currents. Remember, all these are phasor currents. All these are phasor current. So how do we go ahead again? So we can go ahead like this. IS, the total source current would be equal to, this is the total source current. IR, how can I write IR? So see, the voltage drop across the resistor is V, correct? So therefore, I could say this as V divided by R, that is the first thing. And then IL will be what? IL will be V divided by J into XL here. And IC will be V divided by J into JXL, right? So here we have JXL. So here it will be J into omega XC, 1 divided by J into omega XC. Sorry, J into XC you are going to have, right? Reactance we need to write. So let me write down clearly here. So please see, all of you, don't leave anything till the end. It must be written as J into XC. Now moving ahead, so this current IS can be written as V into, of course, inside the bracket it will become 1 divided by R. So let me take few minutes of time, but write everything clearly here. Yes, 1 divided by R here, and plus, what about this one? So this is J into XC, correct? Minus J into XC minus 1 by XL here. correct, XL here. So let me write down clearly here. So Ix can be written as, that means the source current. Now the source current can be written as equals to V into, of course, 1 by R, correct, 1 by R plus J into omega C minus, oh sorry, J into XC. XC means what? XC is going to be omega C, right? So 1 by J omega C, 1 by J omega C. So that is coming omega C, fine. So this is exactly what you supposed to get here, correct? So please look at this, exactly you will going to get this. Now the most important thing is, when you write exactly like this, the current is equal to voltage into, what should I say this one? Any one of you from your side? Can you speak in Hindi? Rupesh Kumar is asking, can you speak in Hindi? If I speak in Hindi, then it is difficult for you to understand, okay? So thoda aa sakta hai, but it is very difficult, right? So V into the total value here. So what should I say here? All put together, Is will be equal to the total voltage into this total, whatever you write here. This is called as a admittance here. This is called as a admittance. Y is called as a admittance. I hope you understood this one. Now, as I said earlier, in parallel circuit, especially at resonance, right? So you see, at resonance, what is happening at resonance? At resonance, you all can see the value of the impedance is maximum, that is equal to R. Value of impedance is maximum. What does it mean? It means that the value of the current is minimum. The value of the current is minimum, right? Value of the current is minimum, and especially to get the minimum value of the current, the admittance must be minimum, correct? So the admittance must be minimum. The admittance can be minimum. The admittance can be minimum only when this part is equal to this part. Clear? So that means once again I can say at resonance, please try to understand clearly. At resonance now, you will be seeing that omega C is equal to 1 divided by omega L, and successfully we can say once again omega R square is equal to 1 divided by LC. Therefore omega R could be written as 1 divided by under root of L into C radian per second. Simple, very simple to understand. Am I right? Very, very simple to understand. Omega R is equal to 1 divided by under root of LC. Same value like what we got even in the series RLC circuit also. Correct? Now, we all can see, especially in parallel resonance, so parallel RLC circuit. This is parallel RLC circuit. What happened? Exactly at omega R, admittance is minimum. So, we all can see at omega is equal to omega R, we understood that omega C is equal to 1 divided by omega L. This is very fortunate to see, and therefore the admittance is equal to 1 divided by R. Am I correct? So please see, one step go back and see. So when I say omega C is equal to 1 divided by omega L here, omega C is equal to 1 divided by omega L, then what will happen? It will become 1 divided by R, right? So that's what exactly I told you. Y is equal to 1 divided by R. So therefore Z is equal to R. Clear? Z is equal to R. And this is maximum impedance. This is maximum impedance and Z is equal to R. Now all of you please look at this and tell me if exactly this is what we are having, impedance Z is equal to R. Can you tell me what is the current that is flowing, especially through what you say like the current flowing through the inductor? How can I write the current flowing through the inductor? Current flowing through the inductor, of course that is not required, so it will become so lengthy, but I hope you got the clarity here. The maximum and minimum impedances calculation I have made it clearly. Exactly opposite. Yes, I will be minimum, that's all. Very good. I hope you understood the point very clearly, and even I have made successfully whatever we have seen here. Now if you look at the current point of view, the current exactly at omega is equal to omega R, current will become I minimum. Current will become I minimum. So if current becomes I minimum, then tell me what will going to happen here? At omega 1 and at omega 2, it will going to become now, if you see, 2 times of the power. So in fact, root 2 times of I minimum we are going to have here, right? Again, here we will use at omega is equal to omega 1, you must have root 2 times of I minimum current. So if you follow the same approach like what we have followed, then obviously the bandwidth here, so let me write down clearly because I can't derive this. If anybody want the derivation for this, you can refer my recorded lectures, because already for series RLC circuit I have done, it is taking a long time. So let me use for parallel RLC circuit directly the formula here. Any one of you, can you tell me what is the formula for this? Any one of you? Any one of you? I will give some time to you. So please think and let me know what could be the formula for this. I will give at least 1 minute for you. Think and tell me what is the bandwidth for this one. Bandwidth. 1 by, oh wow, very good. I think I'm sorry, you are very clear about these things, right? So 1 by RC. Good. Bandwidth will be equal to 1 divided by RC. And there it is going to be what? In series RLC circuit it is R divided by L. Very good. Very good. Let me move to the final slide here. And we have seen that at resonance, so as we have seen again, XL is equal to XC, that we have obtained already. And most importantly, so impedance, that is Z must be equal to resistance R at resonance. So we don't require the voltage across the elements. Rather now we will be seeing the current through the element, current through each and every element. So current through each element. So if you want, you can find out what is the value of the current through the element and find out what is the value of the current through the capacitor. How do we find the current through the element? Current through the element L is actually, IL is nothing but voltage across the inductor into admittance of the inductor. Likewise we can do, isn't it? Right or not? So if you want, you can see all the way the current. So I can say voltage across the inductor, that is quite parallel, it is going to be same. V into the impedance, admittance of the inductor. Admittance of the inductor could be written as 1 by omega L. 1 by omega L is going to be admittance of this one, right? So therefore V could be written as equal to, otherwise let me give this as the homework to you, because already I have done a lot of things. I need to do at least one question for today, otherwise you will cry about this. Now this is a homework to you. Just calculate IL and IC, and then you will understand that parallel RLC circuit will act like a magnifier of the current. Magnifier of the current. I hope you are understanding, magnifier of the current. Series RLC circuit will act like a magnifier of the voltage. That I have proved and I have shown to you, right? So you also enjoyed that. Now this one you try to do by yourself, then you will really enjoy it, right? So you will understand that IL is equal to IS into some quality factor will come. Similarly, IC is equal to some quality factor into the total circuit current, you will go indicate it. Clear? So hope you understood this. Now let me go to the summary fast. So impedance at resonance, impedance Z is equal to R. This is what we have seen. And the resonant frequency is omega R. What is the value? 1 by under root of L into C radian per second particularly. And then third one is current through the circuit. So what is the current through the circuit? Current through the circuit, obviously you will going to have only IS, right? But what is more important to understand is the bandwidth, right? So bandwidth we have calculated so clearly. What would be the bandwidth here? Bandwidth is already Ansari told that this is going to be equal to 1 by RC radian per second here. So this all the way it is important, and we require quality factor. How do we find the quality factor? Can anybody say? So quality factor calculation is important. Let me write down quality factor calculation. Quality factor is equal to 2 pi into energy stored in the inductor or energy stored in the capacitor, correct? So energy stored in the capacitor could be written as C into V RMS square, correct? V RMS square or half CV square. Half CV square or CV RMS square, both are going to be same. Both are going to be one and all same. Now here we are going to have energy dissipated across the resistor. That could be written as Vrms square divided by R. Of course, it should be multiplied by time. Then only you will going to get power into time, that is nothing but energy. So moving ahead, we can say 2 pi by T here into Vrms square, and Vrms will get cancelled. Because in parallel RLC circuit, voltage remains same across the resistor and across the capacitor and across the inductor. Therefore, this could be written as, one second, yes, quality factor is equal to 2 pi by T into R into C without any doubt. Therefore, this is equal to Q is equal to omega into R into C. Omega into R into C. And this can be written as omega C into R. So, this is basically nothing but what? It is equal to, if you want in terms of inductor, then what it will going to become? Everything remains same. Just it will become R divided by omega L. It's a ulta. It's a reverse of series RLC circuit. A reverse of series RLC circuit. And today, whatever the summary I am giving right now, that will really help you a lot even in the final gate examination also. Clear? So all of you, please tell me how many of you enjoyed today's session. So Amsari is too much enjoying, I guess. Amsari, Rupesh Kumar, Surya, Ashok, Chandrasekhar, Chandu, Pramit and Navya, Ramya, please mention all of you. Is it clear to every one of you? I think I have moved little bit fast, but that speed is required because anyway you are going to have the summary slide with you, and for final examination summary is very important, right? So enjoyed. Thank you very much. So the first question, question number 1, this is a simple question. I have taken it from the previous BRC examination, but I agree that this is a very simple examination, not the gate level exam, a gate level question. A series RLC circuit has a resonance frequency, that is, this is resonance frequency FR, correct? This is resonance frequency FR. And going ahead, and the quality factor is 100. Very good. If R and L and C is doubled from its original value, then the new value of the quality factor is what? New value of the quality factor is what? So first of all, try to understand like this. Yet omega is equal to omega R, which is actually nothing but 1 divided by under root of L into C radian per second specifically. What is the way how we can write down the quality factor? Quality factor, this is a series RLC circuit. Series RLC circuit means it is omega L divided by R. Quality factor is this. But remember this point, sir, bandwidth is inversely proportional to the time constant. Yes, yes, correct. So it is omega R into, wow, wonderful. That way you can make it easily. Madhu, excellent. You are right. So omega R into L by R. Usually what is the time constant? L by R. Bandwidth is coming like R by L. Yeah, excellent. You can remember like that. So omega R into L by R. Madhu, very good Madhu. Excellent. You have really made it wonderful. Omega R into L by C. So now put it all the way and tell me what is going to be the quality factor here. So 1 divided by R into 1 divided by root of L into C and particularly L here. So therefore quality factor can be written as 1 divided by R into under root of L divided by C. So this is the quality factor formula in terms of R and L and C. In terms of R and L and C. Now he is saying that R, L, C all are doubled. Then the new value of Q is what? So I could say that, so it is Q1. So Q1 is equal to likewise like this. And in case if Q2 is equal to, what should I say? 1 divided by R2 into under root of L2 divided by C2. What should I say here now? It is equal to 1 divided by 2 times of R1, particularly 2 times of R1. R2 is equal to 2 times of R1 because the resistance is twice. And similarly here, what you will going to get 2 times of L1 divided by 2 times of C2 here, correct? 2 times of C2. Then anyway this is cancelled here, so it doesn't matter really. So 2 will get cancelled. So this is here 2 will get cancelled. So it is L1 by C1. Now I can say all the way this is 1 divided by 2 into Q1. What is the quality factor in the first case? 100, right? So therefore it will be equal to 100 divided by 2, which is equal to 50, The final answer for this question is option B. Option B, Q by 2. Ansari has given the answer. What about other guys? You must be very fast, right? So, very good. How many of you got 50? 50. Chandrasekhar, very good. Option C is the correct answer. Now, let me show one question, because Premit have already asked about this calculation of, resonant frequency and quality factor. Quality factor I have explained how to do in both series RLC circuit, parallel RLC circuit, but the formula and the method what I have given, that is universal for every question. Clear? Now come back to this one. Find the resonant frequency of the circuit shown below. Now you see, it is a circuit. Altogether it is going to be a circuit. So let me ask a simple question from here. So from here to here, it is a circuit, right? So plus and minus. If I call this as an impedance Z, altogether this is an impedance of Z. So at resonant frequency, Z must be purely resistive. Z should be purely resistive. This is the only option you are going to have in every question, purely resistive. Every time you have to keep this in your mind. Please try to keep this in your mind. How do we get Z here now? First of all, Z1. What is Z1 here? And inductor and capacitor both are connected in series. We don't know what is the frequency, but Z1. Look at Z1. Z1 is omega into L. So that is omega into L. So 4 omega L. So let me write down like this. And plus 1 divided by omega C. Am I right? 1 divided by so J into omega L and 1 divided by J into omega C. Correct or not? That is actually this one. And moving ahead, L is not known, L is 4. So it is J into 4 omega, J into 4 omega, because omega we don't know, L we know, right? Well, L we know. So J into 4 omega plus 1 divided by J into omega, C is 1. I am just calculating the value of Z1, nothing else. Only calculation of Z1 I am doing. Because if you want to calculate Z, you require Z1 and Z2 parallel combination of that, and then with series with the 10 ohm resistance. Correct? So therefore, moving ahead, Z1 could be written here as, so how can I write this one? So it is going to be J times of 4 omega and minus J times of omega. Simple. J times of omega. How much it will going to become now? So, sorry, J times of, I'm extremely sorry. It will going to become like minus J times of omega here. This is your Z1. This is your Z1. So, Madhu, imaginary part should be 0. Imaginary part take as 0 while we find the resonant frequency 0.25. Imaginary part, yes, imaginary part, every part we cannot take imagine. So we have to calculate the overall imaginary part and then make that imaginary part is equal to 0. You cannot keep imaginary part equal to 0 at Z1 itself. Please try to understand, there is a lot of difference, right? First of all, we need to find the total equivalent impedance, and then only you have to keep imaginary part is equal to 0 to get a purely resistive form, right? So for that we need to do this. So Z2 is what? Z2 is equal to 1 divided by J omega C. This is the pure capacitance here, 1 by omega C. So therefore I could say this as minus J divided by omega. Simple. Minus J divided by omega. Now look at Z1 and Z2 both are in parallel. If both are in parallel, total equivalent, yes, very good. Z1, Z2 are in parallel. Z1, Z2 are in parallel means only for this equivalent impedance. How much you will going to get it? Let us call this as a Z dash, right? So Z dash must be written as equal to Z1 into Z2 divided by Z1 plus Z2. That is, two impedances are in parallel. So Z1 into Z2. So multiply Z1 and Z2. So it is going to become like J square minus 1. So J 4 into omega divided by omega. So this is 4 first of all, and then minus. So minus plus, and J into J minus. So minus 1 by omega square. This is what you will going to get in the numerator. Please correct me if I make any mistake in the calculation. So J into J, that will get cancelled. J into J, J square minus 1, so plus 1, so 4, that is correct, and plus j into j minus 1 by omega square. Excellent. And all the way divided by z1 plus z2. What is z1 plus z2? z1 plus z2 means it will become like j times of 4 omega undoubtedly minus 2 times of j divided by omega here. Clear? 2 times by omega, right? Taking admittance and then imaginary part should is equal to 0. Well, you can do that. Try to do and let me know the answer. Don't explain me the procedure. You please complete Madhu and let me know what is the final answer. I will be happy if you keep the correct answer. So, however, z dash we have calculated now after a lot of hard work. Now, what is the z value here? So, z dash, let me write down. Z dash means the overall parallel combination here. Overall parallel combination, how much we got it? Z dash, just look at the previous here. So 4 minus 1 divided by omega square whole divided by just go back here, j into 4 omega, j into 4 times of omega minus what else is there, 2j omega, am I right? So 2j omega minus 2 times of j divided by omega here. Clear? Now obviously if you multiply still properly you will going to get it as 4 times of omega minus 1 divided by omega in the numerator, because it go and multiply in the numerator, and of course in the denominator what you will going to have. So in the denominator you will be having like j into 4 omega square and minus 2 times of j, right? So minus 2 times of j. This is what you will going to get as imaginary part, sorry, this total part here, right? So therefore it could be written as minus j into all the way as 4 omega minus 1 divided by omega whole divided by 4 omega square minus 2 here, 4 omega square minus 2. This is considered as your z dash, right? This is considered as your z dash. But what is your equivalent impedance? Have you remembered? This is your equivalent of impedance, right? So that means from here to here, whatever we are going to have, that is your final impedance. Therefore, the final impedance could be written as Z, which is equal to 10 ohm resistance. So let me write down 10 plus additional to that, this has to be Z dash. 10 plus Z dash, that is equal to Z. 10 plus Z dash equal to Z. Therefore, we can say 10 plus Z dash. This is one way to write. And of course, this is equal to 10 minus j into, so what is there now? Now it will be like 4 omega minus 1 divided by omega whole divided by 4 omega square minus 2. Correct? Now you can confidently say that in the impedance part, the imaginary part should be equal to 0. The imaginary part must be equal to 0. Correct? Okay, now I understood that the impedance of this whole should be equal to 0. Madhu, I got your point now. Okay, I hope you are aligned with me. Even I think you have done faster than me. I really appreciate from the bottom of the heart. Okay, so for this part, this imaginary part, now it must be equal to 0. How do we get this one? So therefore we can say 4 omega minus 1 divided by omega all the way, this must be equal to 0. So relax, slowly do this one. So from this, again 4 omega, so this has to be 0, right? So 4 omega square minus 1 is equal to 0 and omega is equal to 1 divided by 2. Am I right? So please look at that. 1 divided by 2. Do you have that value? It is equal to 0.5 radian per second. But Madhu, I think your answer is wrong, right? Yes, 0.5. Good. Good, Surya. Excellent. Right? So option A is the correct answer. Option A is the correct answer. Technically speaking, this took some time, but this is the way you need to follow. If you use here and there some magic and formula here and there, ultimately it may converge to the wrong answer. Sometimes, not sometimes, most of the times it is better to believe the basics. Then you may ask a question to me, sir, GATE is a competitive examination. If you start doing everything from the basic, how would you manage the time? See, Chandrasekhar asked this question, how I have qualified 11 times in GATE examination. The answer is simple. I have never gone to hi-fi formulas. I never use so many hi-fi formulas, and I am not that kind of human. I am just a human, right? So I am not a machine. I can't remember thousands of formulas. Rather, I practice so many of questions. when I practice so many of good questions, quality questions on the formula, automatically the formula will be remembered. And most important thing what I have done, especially in my GATE preparation, is I always used to discuss with my friends. So even I remember during the time when I prepared for my GATE examination, I have a very small board in my home. I remember that I had a small board in home, and all my co-students are sitting in front of me. I used to teach. So when I am teaching that, it is like a discussion. It is like a mutual discussion. When I share that, automatically I was able to remember the formula. I have never done any, great things to remember the formulas. Rather, I used to discuss so regularly with my friends, and that is how I actually remember the formula. That's why I'm saying that if you are very serious, try to go for mutual discussion with another serious and sincere aspirant, and don't spend more time with the students who are not so sincere and waste your time. This is the only one good suggestion I can give it to every one of you. Be sincere at your work, and while it comes to the revision, think that mutual discussion is always helpful to you. If you are not a kind of person to discuss with the others, then at least you act like a split personality. Assume that your friend is within you, and you try to close your eyes and recollect every concept and explain to your friend, your inner friend, so that you don't require another person. Naturally, you will be able to remember everything. Clear? So fine. Chandrasekhar sir, this year also can we expect questions on this topic? See, every year, most of the time, 99% you will be having the question from the concept of resonance. And I have solved, for time being, as I have very limited time, I have solved only 2 questions. But if you want more number of questions, please refer the recorded lectures, or else please refer the previous year questions. Where do you find the solution? And that is the way you can improve yourself. Hope all, sir, do you know Tamil? I wish you to. Yeah, Vetri Surya, you can speak in any of the language, no problem. Okay, so I know Tamil anyway. So Madhu, how to calculate quality factor when series and parallel connection connected both are there? See Madhu, you must think like this. Whether it is series network or parallel circuit doesn't matter. When you are looking at the quality factor of any particular element, just look at that. What is the total energy that is stored in that particular element divided by what is the overall energy that is dissipated in the circuit. That is how we can catch the quality factor. Because the quality factor is nothing but what? How much amount of energy is stored in the element divided by the energy dissipated. Correct? So that is how you need to habituate. Never think like for a series network I will use something else, parallel network I will use something else. Clear? So how to concentrate long time hours? Long time like 2 hours, sir. See, I'm sorry, there is nothing, no thumb rule is there. Whether you have to prepare for 2 hours continuously, 4 hours continuously. If you cannot prepare for 2 hours continuously, if you can prepare only 1 hour continuously, prepare only for 1 hour. Prepare only for 1 hour. After that, if you want to use the WhatsApp for 10 to 15 minutes, strictly use for 10 to 15 minutes and throw it out the mobile and again get refreshed and again come back and sit and study. Clear? Never try to be so much disappointed about the things which are not there with you. Always try to utilize your strength to the maximum level. That is the best thing you can do. For example, I am very open to all of you because you all are very, very matured students. I am not so good with the English. Okay, when I was a student, as I was from Telugu medium student, so I was not so good with the English. So when I was not so good with the English, obviously I remember the year when I wrote the exam for the very first time. At that time, English was introduced. So fine, it's okay. What else I can do? I cannot go to IIT and fight with the IIT people. Why you have included the English, right? So they will smile at me. They will laugh at me, right? So what I done is, okay, let's leave that 7 marks and concentrate on remaining 93 marks effectively. And that brought a very good rank to me. See, that is what I am saying. Some of you may have the strength to sit and study for 4 to 5 hours. I appreciate. Some of you may study for 1 hour and then take the break and again go for 1 hour and take the break. No problem, right? But whatever the time you are studying, you have to put 100% of your mind and make it to quality level. Quality of time is very important. Qualitatively you must use the time. Clear? Right. So Vanya, feeling disappointed and demotivated after the test series, sir. Yeah, Vanya, this happens every time. Not only you, almost I would say 99% of the students it happens. But I always say this point to every one of you. You should not compare with the others. Why you get demotivated is you would start comparing with the others. Others might be scoring very well and your score is less. That is one reason for demotivation. Always try to see yourself, compete with yourself, compare with yourself, right? So yesterday you have attempted the first test. How much score you got? 35 marks. Today you have attempted one more test and you got 40 marks. Great, that is an improvement. Nobody can get 100 out of 100 in the second test, right? So there is an improvement. You should be happy about the improvement. And then from that you have to take to the next level. The third exam you should aim for more than 40. If you are getting less than 40, don't get disappointed because you are almost near to 40, right? So again, whatever the concepts you are doing the mistake, go back and revise that. But always remember this. This is very, very important point. Vanya, I am speaking with you. I am exactly speaking with you. Please listen. If your brain is working at a speed of X in test series, in final gate examination, it will work with the speed of 4 times of X minimum and great accuracy, because your brain also knows that final gate examination is very important. So your brain is so conscious at that time. The only thing is you need to control the emotion. That's all. Okay, Vanya, I think I have conveyed the message to you, right? Never get disappointed. So life will not end only with the gate examination. Whatever the maximum you can do, you do it sincerely. Rest of the things, leave it to the God. Okay. So Vanya, is it okay? Chandrasekhar, do you know Telugu also, sir? Yes, I am Telugu. Chandrasekhar, I am from Andhra Pradesh only, right? Okay. So great to see all of you guys. You are so sincere students. All the way you have attended all 5 lectures. Now I would like to tell you, coming Sunday, we are having a mentee war on circuit theory. I request all of you please attend for the mentee war and try to solve the quiz which is mentioned. In fact, we will be in live quiz. I will be showing the question and giving the time like 2 to 3 minutes depending upon the strength or level of the question, and you have to answer that question. Of course, the topper of the quiz, the top 3 or 5 students will be awarded. So please don't miss the mentee. We will be having the mentee sharply at 7 p.m. or 8 p.m. on BYJU'S Exam Prep channel only on circuit theory subject. So let's meet on coming Sunday evening. Thank you very much once again. Take care about all of you, and bye bye. All the best. Thank you.